Hello and welcome to the video on VLSI testing. In this video, we are going to discuss the sequential controllability and observability. In the last video, we had discussed the combinational controllability and observability. So, when we have the sequential circuits, then we talk about the sequential controllability. So SC0 and SC1. This is the sequential controllability for 0 and sequential controllability for 1. So they basically measure the number of times a flip-flop must be clocked to control a signal. So let's say we have a sequential circuit. So here we have a this AND gate. The A and B are the inputs of the AND gate and D is the output. Then this output of the AND gate is going into a D flip-flop. So here D is the input, Q is the output. We have a reset signal and we have a clock signal. So the combinational controllability of 0 for D will be equal to minimum of combination controllabilities for A and B, because for D to be 0, either A should be 0 or B should be 0 plus 1. Plus 1 we are adding because the signal is passing through a logic gate. But when we talk about the sequential controllability, then you can see that there is no plus 1 term is coming, because in sequential controllability the plus 1 term comes only when the signal is passing through a sequential circuit like a sequential latch. Similarly, you can see that CC1 of D, that is the combinational controllability of 1 for D, is equal to CC1A plus CC1B plus 1. But the sequential controllability for D does not include the plus 1. So it is simply equal to sequential controllabilities of 1 for A and B. Now let us consider this D flip-flop. We have this signal D. Now it is the input to this D flip-flop. So we want to control this data output Q to 0. We want to control this Q to 0. Then either what we can do is apply the input D as 0, reset as 0 and apply a clock signal. This is a positive edge triggered clock, so we will apply a rising clock edge to the clock. Or we can apply a reset equal to 1 and clock should be at 0 only. In these two ways, the output can be set to 0. The first way is when we keep the D input as 0, reset as 0 and apply a positive clock edge to this clock signal. Or we can apply a 1 to the reset while holding the clock at 0, means no clock edge. So now see this, the combinational controllability of 0 for Q will be equal to the minimum of CC0, means the 0 for D plus clock. So 0 for clock plus 1 for clock means a positive edge triggered clock is coming through. This means the positive edge triggered clock plus combinational controllability of 0 for R, means we want to keep the reset at 0, or we can keep the reset at 1 and no clock edge should be there. No clock edge should be there. That is why we only consider CC0 of clock, means clock edge should not come. So now you can see, when we convert this combinational controllability to sequential controllability, then we are adding a plus 1 term only here. We are not adding the plus 1 term here in the second option, because here we are not having any clock edge, means the sequential, means the signal is not passing through this circuit. So this one is added only when we have a positive clock edge. Like here we were having the positive clock edge, that is why this one was added. But here we are not having any clock edge, we are keeping the clock just at 0 and applying the reset, means when we apply the reset, obviously the output will be 0. So and no clock edge should come, so the clock should remain at 0. That is why, because of no clock edge, we are not adding any 1 here, whereas we are adding 1 here for SC0, means the sequential controllability of 0 for Q. So this point is must to be understand. Now similarly, CC1 of Q means we want to control this output of this D flip-flop to 1. So the only way to control it to 1 is to apply this D input as 1 and reset signal as 0 and have a positive clock edge or a rising clock edge. This is the only way we can set the Q input to 1. By having this D input as 1, reset signal and 0 and a positive clock edge, means the clock should go from 0 to 1. So the combinational controllability of 1 for Q will be equal to 1 for D, means we want to set the signal D to 1. Then we want to have a positive clock edge. So first clock should be 0, then clock should go to 1, and we want to have the reset at 0. So again, when we find the sequential controllability of 1, we add 1. Because why we are adding 1? Similar, like I discussed earlier also, because we have a positive clock edge. So whenever we are having a clock edge, then we add a 1 here. In the combinational controllability, whenever the signal was passing through a logical gate, that time we were adding a 1. But here we add 1 only when there is a clock transition from 0 to 1, because we have a positive edge triggered flip-flop here. Now we want to do the calculations for the observability. We have till now done the calculations for controllability. We want to do the calculations for observability. So suppose we want to observe this D input. So it can only be observed at this output Q, because this D input is not a primary output, it is a pseudo primary input. So this D input can only be observed at this output Q by holding the reset signal at 0. We have to hold the reset signal at 0 and a positive clock edge should come. Then only we can observe this D at Q, because then only when the reset is 0 and a positive clock edge comes, then only this D input will propagate to the output. So this will be equal to combinational observability of Q, because we want to observe Q, plus clock signal going from 0 to high. So this CC1 of C plus CC0 of C denotes the clock signal going from 0 to 1, and reset should be 0, because if reset is 1, output Q will always be equal to 0. So similarly, we can from this combinational observability, we can calculate the sequential observability simply by adding 1 here. So this should be SC0. This is not CC0. This should be SC0, because all are sequential terms. So sequential observability for Q plus sequential controllability of 1 for clock plus sequential controllability of 0 for clock plus sequential controllability of 0 for reset plus 1. Why we are adding 1 here? Because we are having a clock transition from 0 to high. So now we want to observe the clock signal. So there are only two ways to observe the clock signal. Again, the clock is a primary input, but it can only be observed at the primary output Q. So what we can do is we can set the Q to 1, we can set the reset to 0. We will set initially Q will be 1, reset will be 0, and apply the D input as 0. So when we have a positive clock edge, then Q will change from 1 to 0. That is the first method. First method is what? Initially Q is equal to 1, D equal to 0, and reset equal to 0. Then apply a clock edge. So if clock edge comes, then this D value 0 will be propagated to the Q output. Or We can set both Q and reset to 0. We can set Q to 0, reset to 0, and set D to 1. Again, this value D, which will be 1, will be propagated to the output Q when we have a positive clock edge. So we are having two conditions here. So in this first, we are adding the common terms. So so the for the observability of clock, we must be able to observe the output Q. We must be able to have a positive clock transition. So these two terms denote a positive clock transition. Then the reset must be 0. Then we can have two conditions: D can be 0 and Q can be 1, or D can be 1 and Q can be 0. So similarly, if we find the sequential observability from here, then we will have to add +1 here, because there will be a transition from, because there will be a clock transition from 0 to high. And finally, to observe the input of AND gate at D, we have to set the other input to 1. So SC0 of A will be equal to S0 sequential observability of A will be equal to sequential observability of D plus sequential controllability of B to 1. Because the output equal to A dot B, so we can observe the A at output only if B equal to 1. Similarly, as the sequential observability of B will be equal to sequential observability of D plus sequential controllability of A to 1. So this is the basics of how we can calculate the sequential controllability and observability measures for this sequential circuits. In next video, we will discuss some numerical on this. So please like and share the video and subscribe the channel.